Hello everyone, in this lesson what I'm going to be doing is solving a simultaneous equation with the process of elimination. Now the assumptions for the lesson is that you know how to perform algebraic operations such as addition, subtraction and multiplication. You know how to identify the coefficients of a term. You know what the magnitude of a value means. RHS means right hand side, LHS means left hand side, and you know how to identify a linear equation, and you know how to solve for one unknown algebraic term. Whenever you have a pair of linear equations, they would look something like this. And the a, b, c, d, e, and f just simply represent integers. The reason that we call these equations linear equations is because you can actually take the equations and make y the subject of the formula, and you'd be able to get an equation that looks exactly like a straight line equation. The good thing about simultaneous equations is that the two unknowns in both of the equations have similar pairs. In other words, the y in equation 1 and the y in equation 2 are the same value, and the x in equation 1 and the x in equation 2 are the same value. Therefore, this means that we can actually subtract or multiply so long as the magnitude value in front of them are the same values. And as you would see in the process, it is clearly stated. So the process for solving elimination, the first one is, the objective when solving a pair of linear equations is to find the terms that have equal magnitude, or make one pair of equal magnitudes through multiplication. Next, you add or subtract the left hand side of equation 1 to equation 2, and the right hand side of equation 1 and equation 2. This eliminates one of the terms. Now, if you have similar magnitudes with opposite signs, what you would do is just simply add. And if you have similar magnitudes with similar signs, you'd simply subtract. So just repeating, if you have a plus and a minus, or a minus and a plus, you would add. And if you have a minus and a minus, or a plus and a plus, you would simply subtract. And you would see what this looks like. Next, you take the result from the addition or subtraction of the equations, and you would end up with one equation that you can solve and get one of the unknown terms. You would use the result from solving and substitute the result into one of the equations, it doesn't matter which, because they both have the same x and the same y values, and just determine the value of the other unknown. The best equation to use is the one which has a term containing the unknown variable with a coefficient of 1. Otherwise, you just simply choose the equation with the lowest term. The math will be faster if you do it this way. Finally, you state a conclusion for both of the unknown variables, and that's the end of your solution process. So we'll look at a couple of examples. The first one that we'll be looking at is similar positive signs. So I have two equations here, equation 1 and equation number 2, and you must label your equations so that you can actually make reference to it when you're doing your steps. For example, when I say subtracting equation 2 from equation 1, you know exactly what I'm doing. Notice in the statement that follows, what I did was I take the left hand side of both equations and I subtracted them from each other. And then I take the right hand side of both equations and I put it on the other side of the equal sign and I subtracted them from each other. Next, all I have to do is just simply simplify, and I'll get a value of y equal to 3. Now this value of y equal to 3 will satisfy both equations. So what I can do is I could take this value of y equal to 3 and I could substitute it into any one of the equations. I will be choosing equation number 2. Notice when I replace it, I get 3x plus 3 is equal to 9. And when I solve for x, I get that x is equal to 2. My conclusion statements therefore look like, therefore, x equal to 2 and y equal to 3. In example number 2, what we're going to be looking at is similar negative signs. Notice again, I have my two equations labeled, and I have my 4x minus y and my x minus y. And the negative sign is the same in both of these instances here. When I subtract them from each other, I would get something looking like this. Again, notice my left hand sides is what's subtracting and my right hand sides is what is subtracting. When I expand and simplify, I would solve for a value of x, and I would get that x is equal to negative 1. Using this value of negative 1 in equation number 2, I will be able to solve for my value of y by simply making y the subject of the formula. I will get y equal to 4. The reason I chose equation number 2 is because equation number 1 has 4 multiplied by x. In a case where you have higher values, say for example you have something like 20 multiplied by a value would take a little bit of a time to work out. So it's better to simply work with one that has the lowest terms. You state a conclusion statement and you're finally finished. Therefore, x equal minus 1 and y equal to 4. And that's your solution. In the third example, we'll be looking at opposite signs. Notice that what I have here is the same magnitude of values here, the two y's, but the signs are opposite. I have one with positive and one with negative. So in this case, I would add equation 1 and equation 2. Notice again, I take my left hand sides and my right hand sides and I add them together. And then all I do from there is just simply expand and simplify. Notice that the negative 2y and the positive 2y will cancel each other out. And what I will end up with is 4x plus 12. I solve for x and I get x is equal to 3. Now I use this value of x equal to 3 in one of the equations. I'm choosing equation number 2. Again, because it have no coefficient to multiply by that x. I will end up with 3 minus 2y, and then I'll have minus 2y equal to negative 4, and y is equal to negative 4 and negative 2, which is equal to 2. And my solution therefore is x equal to 3 and y equal to 2. In the fourth one, what I'm going to look at is where you have no similar terms, but they are of opposite signs. Notice I have notice in equation 1 I have x plus 3y equal to the negative 2. And then I have 2x minus y is equal to 3. What I'm going to do is I'm going to multiply equation 1 by 2. And the reason I'm choosing to multiply equation 1 by equation 2 is because I can actually make this value here 2. And I would have the same sign in front of this so that I'll be able to eliminate them by addition or subtraction. Notice that when I multiply equation number 1 by 2, what I get is 2 into x plus 3y. Notice I also take the entire left hand side and multiply it by 2. And I take the entire right hand side and multiply it by 2. When I actually get this simplified, it will be equation number 3. Now I can use equation number 2, and instead of multiplying by a value of 2, I can multiply equation number 2 by a value of 3. And what I will get is I will have negative 3y here, and I will be able to say, okay, these are of similar value, and I will be able to solve. Alright? So what I'm going to do is I'm going to subtract equation number 3, subtract equation number 2 from equation number 3. And I will end up with this. Notice I'm using equation number 2 and equation number 3. This is the importance of actually labeling your equations as you go along. Next, what you will have is an expansion that looks like this, simplification that looks like this, and you'll get y equal to negative 1. When you use that y equal to negative 1, and you can choose equation number 1, you can choose equation number 2, or you could use equation number 3, it doesn't matter. You would get that x is equal to a value of 1, and you state your conclusion and you're finished. If you have any questions or comments for me, you could message me at karib.tutor@gmail.com. You can leave your message with the video, or you can ask your course teacher for any information that you need and you don't understand here. Thank you very much. Bye.